Okay. So, number 5. All right. Anytime you see the words, okay, radius of convergence or interval of convergence, you need to do the ratio test. Okay, that's how we start those problems. Okay, you're going to do the ratio test and you're going to find the interval whenever for the radius of convergence. So I'm going to do the ratio test, we do the limit as n approaches infinity. What do I have to substitute in? N plus 1. So do I really need to worry about the negative 1? No. Absolute value takes that away, so I'm going to kind of ignore that. So x to the n plus 1 over 10 to the n plus 1. And I'm supposed to divide by n, or I multiply by the reciprocal in this case. All right, from there, what happens? Cancel the n. So x to the n goes and 10 to the n goes. So I am left with the limit as n approaches infinity of x over 10. Is there anywhere to plug in the n? No. So my limit is actually the absolute value of x over 10. At this point, the rule for the interval is to make it less than 1. How do we undo the absolute value? We make it go between negative 1 and 1. Now I get x by itself. So what do I have to do to get x by itself? Multiply by 10. Okay. What is the distance? If I put negative 10 to 10 on a number line, what's the distance between those two? 20, right? So to get the radius, I take that and I divide it by 2, which gets me what? 10. Which is B. All right, what do you want me to do next?
Wait, why'd you divide it by 2?
Because this is more like a diameter. It's the whole thing. It's the whole interval. The radius is only half the interval. Okay? All right, what else? What do you want me to do next? 11? Okay. Oh, yes, the 3 from the board. I think we did all of them last period. All right, so we need the Taylor polynomial of order 3 at x equals 1 for e to the x. So what I told last night and I told them last period is I'm going to give you about no more than 3 or 4 that you don't use the chart for the power series, and then I'll have you switch over and I'll give you the chart. Okay? You can use your convergence chart, the flow chart, the whole test. Okay? So, I'm going to do this one as if I didn't have the chart. Okay? So we practice a few like that. So, Taylor polynomial order 3 means I need to go to the third derivative. So my original is just e to the x, right? Because it says the function's e to the x. My first derivative would be what? E to the x. My second derivative would be, you see why I'm doing this one the long way? Because it's not that bad. Okay. And then I have to go my x minus c. So, actually, I have to evaluate, don't I? For what number? 1. So if I put 1 into all of these, what are they all going to be? Aren't they all going to be e? Yeah. All right, so now I'm going to go into my Taylor polynomial. So my first term is x minus 1 to the 0. And then I do x minus 1 to the first. And then I do x minus 1 to the second. And then I do x minus 1 to the third. All right, then I throw my coefficient in, right? So it's e, 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 e. And then what do I have to divide by still? The factorial. So I'm dividing that one by 2 factorial, and I'm dividing this one by 3 factorial. We throw some plus signs in there. Unfortunately, that's none of the answers. Okay? However, what did they do to most of the answers? They factored out an e. And I could get rid of this thing here, right? It just becomes 1. So 1 plus x minus 1 plus x minus 1 squared over 2 factorial plus x minus 1 cubed over 3 factorial. I believe it's b, isn't it? Or is it e? I can't remember. There's pluses. Oh yeah, it's got to be D, because it's got the factorials in it. C has plus signs, x plus 1 instead of x minus 1. Alright, what else?
Yeah, shouldn't it be cube on the last one?
Is there like a typo?
X minus 1. Oh, I think there's a typo there. Because look at the typos on all of them.
Yeah.
It's my, you know what I did is I probably, when I typed it, I probably copied and pasted.
Wow, misspelled.
And you could see the typo on the whole thing. Thank you for catching that, though. I appreciate that. Okay. Last period didn't say a word. Alright. Alright, what else do you want me to do? 13. Okay, so let me look at 13. You're not going to like this. 13's pretty easy. Alright. Let's say we're going to use the chart this time. Okay? So, I want you to look at your chart, and I want you to find your series expansion for e to the x, and read it to me. Mm-hmm. Plus dot dot dot, right? What does it say we're going to put in for x? So let's do that. Plus negative 0.1 squared over 2 factorial plus negative 0.1 cubed over 3 factorial plus negative 0.1 to the 4th over 4 factorial plus dot dot dot. Put it in your calculator. Make sure when you're typing that in, the negative 0.1 goes inside the parentheses. The negative should not be outside the parentheses. All right, anybody got a number? Not yet. Point nine.
Did I do that right? You guys get that?
0.4 what?
Did you forget the 1?
8.
I get the same answer exactly.
It should be this, right? But you have to be really careful and make sure you have enough terms, because look at how close these two answer choices are.
Wait, hold on.
It ends up being that one.
1
All right. Everybody okay on 13? All right. 15? Okay. Let's go to 15. All right, so we've got the Taylor series for that one. This one I put together really weird, okay? So, what we're going to build it a little bit. Okay, so I'm going to start by the simplest function I could get out of that would be the natural log of x. So let's write down the expansion for that. So when I write down the expansion for that, I get what? So read it off your chart. X minus 1 over 2 plus 3 minus I'm going to stop there because I think we can get it off of that. Okay? the thing with this one is you don't want to simplify too fast, because look at some of the answers are left in factorials, aren't they? And with those 2's in there, so let's not simplify too fast. The next thing I'm going to do is I'm going to build it to, I'm going to try to put just 1 plus x in. So I'm going to go to this next. So if I put 1 plus x in for that, so let's think about what's going to happen there. Okay, if I replace that x with 1 plus x, the 1's are going to cancel, and I'm just going to get x's in all of those, right? Okay, so let me go back to my other color. All right, so I would have x minus x squared over 2 plus x cubed over 3 minus dot, dot, dot. All I'm going to do now is put what in for the x? 2x. So I'm going to do the natural log of 1 plus 2x. I'm going to substitute a 2x in here. So 2x minus 2x squared over 2 plus 2x cubed over 3 minus dot, dot, dot. So it's looking like answer choice A, right? If you simplify, which the video I did 4th period, we started simplifying it, it looked like, it starts looking like that one. But it's not, because you end up with the 3 in the denominator. So you got to be careful. Don't simplify too fast. All right, what else do we need to do? 16? Okay. There will be one like this on the test. This is the only example of the Lagrange in the assignment, so it'll probably look really similar to this. Okay? So you have to read a couple of things. First of all, it says we got to go 4th degree. You need to go in and you need to look up that formula. It's not going to be there for you on the test. You already have a bunch of charts. You can figure out and memorize that one formula. Okay? So, it's the remainder formula for the 4th degree. And it basically says in the formula that you have to add 1 to that number right there. So I need to, the formula says I'm going to need to find the 5th derivative of the function evaluated at z, x minus c to the 5th over 5 factorial. Okay, so I'm going to start by finding, my function is cosine. I'm going to go till I hit the 5th derivative of it. So f is cosine x. What's the first derivative? Negative sine x. What's the second derivative? Negative cosine x. What's the third derivative? Sine x. And then the 4th derivative is cosine x. And the 5th derivative is negative sine x. Okay, so now I know that negative sine x, it doesn't, I bet I built it really weird, but it's really the function that would go in there, right? The piece that goes in here is whatever this value is. So 0.2 to the 5th. And then there's a trick to this little chunk right here. Okay? You want that function, the number to go in for that function to be as large as it can be. Large as it can be. What's the biggest number that sine ever gets to? 1. That's why it's going to be a sine or a cosine. We were debating an E last period, but I don't think it'll probably be an E.
Is it always going to be a sine or a cosine?
Most likely on this test, yeah. It's going to be something that you know how large it gets. Okay? What? Yeah. So sine or cosine is going to get as big as 1. All right, so you're going to go ahead and put that in your calculator and tell me what you get. All right, anybody get it? Yeah. I had written down from the year before, had written down this. So, they're both the same thing, right? All right. What else do you guys want to see? 6? Okay, let's look at 6. Okay. So we need to find the interval of convergence of the power series, and we need to check the endpoints for convergence. So the first thing I'm going to do if I'm looking for interval of convergence, actually the first thing I'm going to do is I'm going to rewrite that a little bit. It's really like the same as saying x to the n over 4 to the n, right? Is I need to use which test? There's only one in this end of the chapter, right? Ratio test, okay? When I use the ratio test, what do we have to plug in? N plus 1. So we've got x to the n plus 1 over 4 to the n plus 1. We divide by the n power, or I flip and multiply, right? Okay, so now what happens? The n's cancel. So I cancel all of my n's, and I'm left with the limit as n approaches infinity of the absolute value of x over 4. Is there any effect of the n on this? No. So my limit is actually the absolute value of x over 4. Now is where I add in my less than 1, because that's the rule to create an interval. How do I get rid of the absolute values? Good. In between -1 and 1. All right. And then what do I do to get x by itself? Multiply by 4. Thank you, Greg. All right. Here's the catch, though. It's definitely not D or E. You could guess between those at this point. Okay. All right, Naomi, it looks like you have to go. It says to go do your FAFSA application. All right. So, the next thing so I have to check my endpoints in order to decide if it's going to be parentheses or brackets. So the way I do that is I put my endpoints into, I'm going to put them into that, okay? And I do one of my series tests on it. Okay, this is probably why you need your flowchart. Okay, so I'm going to go for x equal to -4 first. So we've got the sum as n equals 0 to infinity of -4 over 4 to the n. What's that reduced to? It reduces to -1 to the n. Okay. So what test would we use on it? You could use alternating. The first part of the alternating, though, is the nth term test, right? They're really the same thing. So, what does that equal? Does it equal 0? That's all we care about, is whether or not it equals 0. So if it doesn't equal 0, we know it diverges, which means that it is an open parentheses. Just based on that, doesn't it have to be B? Yeah. I'm going to go ahead and do the other side just to verify and to practice, but at that point on the test, I would probably move on. Okay? So if I put the x equals 4 in, it reduces to 1, doesn't it? So 1 to the n. In that case, I would use my nth term test, which is the same as the first part of the alternating series test. Does that equal 0? No. So it also diverges. So it is, in fact, most definitely B. All right. Are there others that we have questions on? Yep, take the pass. You want me to do 5? Oh, okay. We did 5, didn't we? Okay. What else do we need help on? Nothing? Well, tell me what you want me to do next.
do.
I can tell you we didn't do 10 or 14 in fourth period.
Let's do
10?
10. That'll be 14.
Okay. All right. Let me find my... All right, so number 10. Let me get there. All right, so we need to decide where it converges, okay? So the first thing I'm going to do is I got to figure out my power series for it, okay? It looks like it gives me that part. Good. Okay, so I'm going to go ahead and use my ratio test on it and find my interval, okay? So we're going to do the limit as n approaches infinity of, for a ratio test, what do we plug in first? N plus 1. So x to the n plus 1 over n plus 1. And then I divide by n or I multiply by the reciprocal. Okay, I get to cancel anything to the n power. You got to be careful. You can't just cancel n's, right? I could, at this point, if I wanted to, remember how we put that variable at the x out front? You can do that if you want. It's not necessary. Okay, but it's a style. It's a way to go. All right, when I do that, what do you notice about these exponents? They're the same. So the limit is just the numbers in front, right? I got it.
1.
So it's just going to be 1. Okay, so that means that that my limit that I'm really getting off of there is the absolute value of x, isn't it? All right, so and then this is where I throw in my less than 1. All right, so in order to get the absolute value off of it, what do we need to do? Yep, so we're going to sandwich it between -1 and 1, which isn't a surprise. Look at all the answer choices. Okay, it's definitely not E. Okay, so what I need to do now is I need to test the endpoints. Okay, to see if it... Yes, correct. So I am going to put in a -1, and we're going to put it into this original series there. Okay, so we're going to find, I'm going to put in x equals -1 into the sum is n equals 0 to infinity of -1 to the n over n. All right, which test would we use on this, probably? That would be an alternating for sure, okay? I start by doing the limit as n approaches infinity. I take the absolute value of it, right? So I get really just 1 over n, which is going to be what? That is, in fact, 0. So it worked for that part. I also have to check to make sure my terms are decreasing. Again, I ignore the -1 to the n. So if I put in a 1... I get 1, right? If I put in a 2, I get 1/2. If I put in a 3, I get 1/3, and so on. Are they decreasing?
Yeah.
So does it converge or diverge? It converges, which means that it is either closed or equal to. So you can use either that notation or a bracket. They're using the closed, right? Yeah. So by doing that, I've now eliminated A and D. So it's either got to be B or C. No, because one of them is open and one is closed.
No, like one.
Not necessarily. Okay, so let's try it. Because that was a positive one. Okay? Or sorry, this one's a -1. Alright, so let's go x equals 1. A sum as n equals 0 to infinity of 1 to the n over n. I'm not using alternating series this time, am I? No, because so what test can I do on this one? P series. Okay, so here's why you needed your flowchart today. Okay, so P series, what's your P equal to in this one? 1. When P is exactly equal to 1, doesn't it diverge? So it is different, right? So it's going to stay that way or do an open parentheses. So it's answer choice C. All right, you want me to do 14? I know we did it last night, but that's the one we didn't get recorded. Other than I didn't do 1, 2, or 3 either, but everybody knows how to do those, hopefully. All right, let's look at 14. So we need the x squared coefficient of the Maclaurin series for e to the sine x. Okay, so here's what we're going to do. We're going to write out, you're going to use our chart to expand both of those. Okay? So I'm going to write out the e to the x series. So what is e to the x according to your chart? Plus dot dot dot. That's probably enough. Okay? All right, and then let's write out sine x. So we've got, what's sine x? Mm-hmm. Plus dot dot dot, right? Okay. So here's what we have to do. We have to take e and we have to substitute this in to the, can't remember what I did here. It's e to the sine x. So I took and I put in, oh, so I have to make it, oh, okay. What is the, I need the coefficient for x, what? Squared. So all I really need to do is take this and substitute it into the x in there, right? That was quick. That was a good, did you get some good steps in? Okay, just checking. All right, so all I'm doing is taking this and substituting it in for that x, right? So we've got 1. I'm going to pull this factorial out front because all I'm working with is just that term. So it'd be this thing here, this x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial squared. Okay? Read the question. What do they want? The coefficient. Look at your answer choices. Because these are probably going to be negligible at some point. So, yep. Okay, what else do we need to talk about? Are there any others? 12? Okay, let's go back and do 12 here. All right, another coefficient problem. Okay, so I'm going to do this without the chart. Okay, I'm going to go ahead and take my derivatives on this one. And this one is more about simplifying fancy algebra stuff than it is probably about the calculus piece. Okay, so notice it wants me to go to what exponent? The third. Okay, and yeah, we know it's a Taylor and it's centered about x pi over 4. So I'm going to take this thing and I'm going to keep taking derivatives until I get a power of 3 on my x. So I know my original is cosine x, and that would really, if I was thinking about it, be the x to the 0 term, right? And I know it's x minus pi over 4 to the 0, but I'm being really lazy about this. So I need to get down here to the cubed one. So what's the first derivative? Negative sine x. And then the second derivative is negative cosine x. And then the third derivative is sine x. Okay. What I'm going to do from there now is I really don't need to mess with this other stuff. I only need to deal with this guy here, right? Because it just wanted the coefficient on the cubed. So what I'm going to do is I'm going to start by plugging in my pi over 4. So I'm going to find the third derivative evaluated at pi over 4. Or the sine of pi over 4, which is right here, isn't it? So what's the sine of pi over 4? Square root of 2 over 2. Okay, so now what I'm going to do is I'm going to put that in next to I'm going to set up what I would normally do in a Taylor polynomial. And then when we do that, we also have to divide by what? 3 factorial. Okay. What's 3 factorial? 6. So couldn't I multiply this stuff together? So I've got square root of 2 over 2 times 1 over 6. What's, it's square root of 2 over 12, isn't it? Is that one of our choices? What if I do this? 2 over 12 square root of 2. Now do I have one of our choices? So I had to just because it wasn't there to begin with doesn't mean it isn't there. Okay? I don't want your hand raised and say, Mrs. Ballard, there's no answer. You might have to manipulate your answer and do some more math to it. Note, the clue was, look at all those radicals in the denominator, right? I had to get a radical back into the denominator. So you rationalize going the other way. All right, are there any others that you guys want to tackle right now? You tell me. Because there's 10 other ones that we could possibly do tomorrow. So there's 9s left, 8, 7. You may do 8? Okay. Okay, and I think I got a little bit better explanation than those of you that came last night, especially on the power series part of it. Okay. So we know we've got to get this thing in the format of a sub 1 over 1 minus r. That's just the rule. Okay. The first thing I have to do is I have to get this as an x minus 8, right? It's part of all of that. And I have to get it to fit into this denominator. I also want to try to introduce this minus minus business in there. Okay? So to introduce the minus minus, don't I need to distribute in a negative? So really what I'm doing is I've got minus 8 plus 8. But if I'm going to try to fill in a blank here and get it equal to 9 plus x, I need to distribute that negative in again, and I really am looking at something plus x minus 8. So what would I put into that blank? 17. So I'm now going to rewrite this thing with the 17 in the blank. Okay? Actually, I'm going to rewrite it with this whole thing in it for the 9 plus x. So I've got 8 over 17 minus negative x plus 8. But what did I need this first number equal to right here? 1. So how do I get it equal to 1? What do I have to do? We're going to divide by 17. Okay, so I've got 8 over 17 over 1 minus, and I'm going to write this a little bit different. I'm going to say 1 over 17 times negative x plus 8. All right, now I'm going to put that into my general term. Because I know that this can be the a sub 1 times r to the n, right? So what is my a sub 1? Eight over 17. Good. The r is this thing right here, right? This negative, or this 1 over 17 negative x plus 8 all to the n power. But if you look at all of them have an x minus 8, not a negative 8 plus x. So I'm going to rewrite it again. So I've got 8 over 17. I'm going to go ahead and put that n on there. So I'm going to ignore that 1. I'm just going to put 17 to the n in the denominator. I'm going to take out a negative 1 and raise it to the n power. And I've got an x minus 8 to the n power. We're almost at one of these, right? I have to put those 17s together. So if I'm multiplying, what are we doing with the exponents? Adding them. So 17 to the n plus 1. So look at those. That one's gone. All the rest of them have the n plus 1. All right, I've got to have a negative 1 to the n. All of them have that. I've got to have an x minus 8 to the n. X minus... Oh, all of them have that, don't they? And then we've got to have an 8. What's going on? What happened? Did we all... Oh, this was just to the n. That's to the n. We needed it to the n. Just the... I crossed that one out and shouldn't have. The -1 should have been just to the n power, right? So this one's gone and that one's gone. So we're down to A or C. And the big difference between A or C is now the interval of convergence. Okay? See the funny E in there? It means there exists. It's the words there exists. So X exists where on that interval, basically. Okay, so now what I have to do is I have to do a good old ratio test. So I'm going to try to squeeze my ratio test in over here. So I've got the limit as n approaches infinity. I have to put in probably the best simplified one is... Well, there's a couple of... I'm going to go back to this one right here. Use a different color. Alright, so I'm going to go back to this one. If I put this in, and I put it on the top and the bottom, isn't it going to cancel to 1? So I'm not even going to put it in at all. Okay? I'll go ahead and put in the 1/17. Okay? And it's technically to the n power, because if I distributed that in, so I'm going to say it's to the n plus 1 power. Okay? And then I'm going to do the x minus 8 to the n plus 1 power. And then we're going to divide it by the same thing to the n power. To the n power and to the x minus 8 to the n power. What's going to happen now? Yeah, anything to the n power is going to cancel. Oh, I forgot my absolute values. Put those on there. So I really have the limit as n approaches infinity of 1/17 x minus 8. And those are absolute values. Again, n has no bearing on it, right? So we've got 1/17 times x minus 8. And we're going to go ahead and throw our less than 1 on there to get rid of the absolute values between -1 and 1. And then how do I move the 17? Multiply. So we get -17 less than x minus 8 less than 17. And then how do I move the 8? Add it. So we get negative what? 9 and 25. So it's definitely answer choice C. All right. Is there anything else that we need to talk about? Seven. Okay. All right. We need to find the interval of convergence. Interval of convergence, we always start with the what? We got to start with the ratio test. Okay. So in order to do the ratio test, what do I have to substitute in? N plus 1. So we've got the limit as n approaches infinity of x minus 5 to the n plus 1 minus 1, because I'm substituting n plus 1 into that, over 5 to the n plus 1 minus 1, and then I divide by the n, or what the original was, or I multiply by the reciprocal. Or x minus 5 to the n minus 1. Okay, so what's going to happen to these the 1 minus 1s? They're going to cancel. So I've got the limit as n approaches infinity of x minus 5 to the n over 5 to the n times 5 to the n minus 1 over x minus 5 to the n minus 1. Now what happens? Cancel the n's. So that's gone, that's gone, that's gone. Are these guys going to be happy where they're at? No, so I'm going to flip them the other direction. So I'm going to bring my x minus 5 upstairs and my 5 downstairs. Is there any n to plug into? No, so my limit is x minus 5 over 5, and I'm going to go less than 1. Okay. In order to get rid of the absolute values, what do we have to do? Yep. Okay, how do I move the 5? Multiply, good. And then what? Add 5. So 0 less than x less than 10, which is none of them. Now, I don't need to check endpoints because notice how all of them are open. So I'm not going to waste my time on a test checking endpoints. All right, is there anything else that we haven't done yet that you guys want to see? 9. Okay. So we need to do the definition of Taylor series. All right, so what I want you to do right now is I want you to look at your chart. Actually, first of all, if it's centered at 0, what is it instead of a Taylor? It's a Maclaurin. So Maclaurin is a Taylor, right? It's just centered at 0, but more specifically, it's a Maclaurin. So give me the e to the x for Maclaurin. What does it say? Good. Now, I want you to read the formula, the general term. What does it say? X to the n over. Look at all of those. Isn't this what I didn't need this other stuff. I just needed this, right? What do I substitute in for the x? 7. So I'm going to put 7x. Sorry, you're going to put 7x in, not 7. 7x in. All right, so now let me distribute that n in. So I've got the sum is n equals 0 to infinity of 7 to the n, x to the n over n factorial. Is that one of our choices? It's C, isn't it? All right, did we hit everything except for 1 through 4? Is that what we're down to? Okay, so for tomorrow, there is another 10 problems to work on, right? So I would make sure I try those at home in case you don't have time for all 10 in class. Okay? A lot of them are ratio and root test. You guys should be able to do the ratio test in your sleep at this point. Okay? I shouldn't really need to help you study much of that. Okay? If you want something stamped, I am happy to stamp.